I'm Laura, and just curious, how many of you are homeowners? Raise your hand.
How about condo?
Yeah, condo too. And then anybody rent? Okay, so we have almost exclusively homeowners, which is great. You know what, normally I like to just be laid back and say if you have a question, raise your hand, but we've got so much exciting content that I'm just gonna say hold your questions and I'll wait as long as you need to answer them until the library kicks us out. Or as you heard Ross say, MG&E has a home energy line, and I, myself and a number of colleagues answer that line. So if we don't get your questions answered tonight, we can talk offline for as long as you want, which is awesome. That's one of the things I love about MG&E is they just allow us to be of service to our community. And so with that, I'm gonna get started. Ross said a little bit about me. I went to school here in Madison, then I worked at Rayovac at their world headquarters, got to fly all around the world because I spoke Spanish fluently at that time, and get to work on environmental projects at battery manufacturing locations. And then I worked for an engineering firm that did like landfill design and sustainability work. And then I got a calling and I realized that I just loved energy. I just loved residential energy. So I was like, what kind of certifications do I need? What do I need in order to like go and start my business and do this for real? So I did that, and I did that for 12 years. And then MG&E called and said, we think we have a really good position for you. And I kind of laughed at them. But lo and behold, I went ahead and my husband still runs our small family business, but I've done a ton of energy auditing, 12 years, both in existing and new construction. I'm a wife and I'm a mother of 2 girls. So I never get a day off, let's put it that way. Tonight's roadmap, I really want to take you through your home upgrades, and normally I spend a little bit more time on those, but we have so much good content to cover about rebates and tax credits that I'm going to go through that material, but just a little bit faster. We'll cover behaviors, solar, EVs, electrification. And really my intention is that you realize that you can have a very intentional journey with your energy use. Oftentimes when I would do energy audits, people would tell me about all the things they've done over the years. And sometimes I would show up and they'd be so excited to tell me about their brand new windows, but then I would have to tell them you have 0 insulation in your sidewalls. So that was not a strategic improvement, right? Like tens of thousands of dollars of windows wasn't saving them much energy, but the insulation that they needed in their sidewalls would have. So I want to let you know that we're going to cover this energy journey tonight in a very intentional way. There is strategic ways to do this. And the biggest thing is just to decrease your heating and cooling load. So we're going to focus on that. And then we'll talk about technology replacement and behavior change. Then we'll talk about renewables and EVs, and then we'll get to electrification. But I always like to start out with like, what are the facts? Just give me the facts, because when we know the facts, then we know what to focus on. And what I want you to get from this slide is that over 50% of our energy use in a home, it comes down to heating and cooling. So when we think about being strategic, we really need to start and focus on our heating and cooling. And then you can clearly see water heating is after that. So we're going to talk a lot about heating and cooling today. And because a lot of the other ones comes down to behaviors and just products that you purchase, but this heating and cooling is just like, it's really important, and it's what drives us as humans because it's what makes us comfortable. And since we've moved from living in caves to homes, we've realized we can control our climate. And that's cool. Well, actually, sometimes it's hot. Bad joke there. That is cool, but it has an effect on our environment. And that's really where my passion came together about energy, residential energy, where I was like, we've gotten to this place in history where we live very comfortably no matter the weather. But this is coming at a cost. Right? So how can we keep that convenience but decrease our effect on the environment? So I like to be a little interactive in my presentations. So I always like to ask people to put their thinking caps on and ask, what is going on inside of our homes? What are the 3 types of energy transfer? Just Anybody, raise your hand or shout it out.
Conduction, radiation, and...
He said conduction, radiation, and
convection.
Wow, okay, you answered for the whole group. They all need to give you part of their snack, I think. That's how it would happen in grade school, right? You got it right. There is convection. So they always say energy is neither created nor destroyed. It's like, okay, well then what's happening to it? Well, it's transferring, it's moving. How does it do that? Convection. This is a really simple example because we all get sitting by a fire. This is when you have the warm air rising off of the fire. That's convection. Conduction is actually put your marshmallow, rod in there and then it gets hot, right? Because the heat's actually traveling through a solid material. And then radiation, that is heat transferred through electromagnetic waves. We don't deal as much with that. I mean, we have it from the sun, but how does this work in our homes? Like, this is basic science. This is how energy moves, which is actually really cool. And it's important for us to know because we want that energy to stay. So we want it to transfer and stay within our homes. So convection, that idea of energy transfer through movement, this is air moving in and out of our homes, okay? And we get this one because if you feel a cold draft, you know right away. You feel it. And then conduction, we don't really feel this one as much, but we're constantly losing energy to the outside. Because energy is moving through our walls, it's moving through our windows. And then radiation, the third way that energy transfers and how it interacts in a home is mainly the effect of the sun. That's the majority of our radiation. But let's go back. So what did we say the fact was? Over 50% of our costs come down to heating and cooling. So what controls that 50%? How do we wrap our heads around that? What is it that we're looking to control? Well, number one is the house itself. Whether you're in it or not, whether it's little or big, the house actually controls how much energy is transferred. And then the equipment inside it. This is a picture of an old furnace, and I don't know if you ever watched Home Alone, but this is when the little boy's home alone and he has to go into the basement and the furnace looks like it's gonna eat him. But our equipment, right? So first it's the house, just what's the box we're living in and what's that made out of? And then what are we heating and cooling with? And then it's the people inside, right? There's always that human factor. Those are the three main things that control your heating and cooling. Those are the three main things that control your bill. So let's look at that a little bit more. The mechanicals, your furnace and your AC, the equipment we're using, we know a lot about this. If a salesman comes to your house, they'll talk to you about the ratings. We know we want, our furnaces to be 95, 96, 97% efficient. We know these ratings for air conditioning and we know them for heat pumps. So that's pretty well known. And humans, we try our best, but let's face it, we all have those days where we feel a little extra chilly and we go over to the thermostat and we hit the up arrow, right? And so we're doing our best based off of our behaviors. But the home, the enclosure, that's kind of our big mystery when we're homeowners. And that's what we're gonna go through some discovery today. So if this home, if this enclosure is so important, what are these home upgrades? So we're gonna cover these today. The big ones are air sealing, insulation, ventilation, and mechanicals. So you can see this diagram from the Department of Energy. It's these are all the places where your house could leak. It's no small list. And so when you think about making these home upgrades, it can be overwhelming. That's why I love to come and do these presentations because no one ever teaches us this, ever. There's no manual you get handed from a realtor when you move into a house to say this is how your house works. This is what you need to do. Never, right? And so I like providing information where people can feel empowered to make the best decision for them and for their home. But I also like to encourage you to think. So I have to ask, why does heated air, right? Our furnace runs and the heat everything gets warm and toasty. Why doesn't it just stay in the house? Like, what are some reasons, even if you have your windows closed and your doors closed, like, why doesn't that air just stay in the house? I'm not going to tell you. People need to. Air leaks, but like, what specifically is causing the air leaks? How does the air leak? Equilibrium, but how is the equilibrium thrown off?
Convection. Hot air rises through the...
Hot air rises. Okay, so that's one, hot air rises. What other kind of air is going on around our homes on the outside?
It's colder outside. Infiltration.
Wind, the wind, right? So wind affects, if our houses just sat there in a vacuum, that air would just stay in there, right? But we've got the wind, which we cannot control, right? We can plant things strategically on like the west and north side to slow down that wind, but inevitably the wind affects us. And then this is a little bit trickier one, but we have combustion and ventilation happening inside our house all the time, which means we're turning on fans, right? We might have a fireplace, but can anybody tell me what is the biggest like ventilation effect in your home? Like what's the piece of equipment that you use that actually throws more air out of your house than you probably realize?
Chimney?
Your dryer. A bathroom fan could throw like 50 to 80 cubic feet per minute of air out. Your dryer will do like no less than 400 cubic feet per minute. So we have these things we have in our home that are actually forcing air out, and we need them to. We want that dryer to throw that moist air out. But what we forget is for all the air that is thrown out of the house, other air comes in, because you always have the same amount of air in the house at the same time. And we can't really control that ventilation one. We need to run our bath fans, we need to run our dryers, right? But the one we can control was the first one you said, which is warm air rising, and that has a name. That's called stack effect, okay? And it's just as simple as that. Warm air rises, so we can't see it, but all the time in our homes in winter, warm air is rising, it's escaping up into our attics, and then you know what happens? Cold air comes in down low. Because what did I say? The home always has the same amount of air. So you can't have some leave with other stuff not coming in. So it's interesting, right? So remember, like, let's bring this back. We're talking about the house. The house itself is what helps us save energy. And we're talking about how to make it airtight, right? Because we are wanting to keep that warm air in. That's what we just paid to heat. And 25 to 40% of our heating and cooling costs are due to air leakage. But where do you think this is happening? I heard mostly the roof. Well, we're told our windows are leaking all the time and we should spend thousands of dollars to replace them. When in fact, windows only make up 6 to 10% of the total leakage. So where's the rest of the leakage? If you came home every day with a hole in your wall, would you walk right by it and say, oh honey, we should probably do something about that? Yeah, like next week. You would never do that, but you want to know what's happening? Every day, you are walking by that hole until you have air sealing done. Well, where do you have air sealing done? You have it done mainly in your attic. You said roof, but you were getting there because why? Warm air rises. And insulation does not stop air. You have to use other materials. How do we know this happens? because when I would do energy audits and I would set up the blower door, which we'll get into that a little bit later, but it's a big temporary door and it aggravates the leaks and bypasses, I'd bring out my thermal imaging camera and I'd see these dark streaks start coming down the wall. And that's an indication that there's a hole up in that wall leading up to the attic, and I was able to pull air right down that cavity and identify it during the audit. This happens in all walls, not exterior, it also happens to interior walls. So how do we remedy this? Contractors go up into your attic, they'll move the insulation away, and they actually use foam, like Great Stuff, or closed-cell foam, or caulk, and they find all these areas. They're really well-known areas, and during an audit, they'll be located if you do decide to have an audit. So here's an example of spray foam looking down in an attic. Here's the top of like an interior wall. Now, these are all like interior walls where the drywall comes up, but all of this seam, that all leaks air. You might think, oh, but it's just a tiny bit. But remember that big hole in the wall? We do testing on homes and we can quantify this. We know that like the average older Wisconsin home, has like the equivalent of a 16-inch by 16-inch hole that's the equivalent leakage that's happening. Right? But it's in all these places we don't think, in the attic. So here's another picture of like, they move away the insulation and they foam the tops of all of these things. But it's not just the tops of walls, it's even small things like electrical boxes. So and then here, like that up there, the electrician will come in, and we love our electricians, but they'll drill a hole, run their wire, and they don't seal up the hole. But we know that warm air rises, so all of these holes add up. Even things like plumbing vents, they were never sealed back in the day. So all of these things are allowing warm air to rise, leave up high, and cold air to come in down low. And every time I did a computer model, attic air sealing was the best return on investment, but nobody ever talks about it because it's the least sexy, least fun thing to talk about. You do not go to a dinner party and say, guess what we just did, Paul? We air sealed our attic. You just don't. You usually tend to tell people about your new countertops or your windows, but this is your number one improvement. If you haven't had this done to your house, and even if your house was built 10 years ago, it's likely your builder may have not done this. And air sealing, a contractor will seal up all these nooks and crannies, and it's the equivalent to wearing a windbreaker. Have you ever gone outside with just like a sweater on, but it was really windy? You weren't comfortable because you didn't have anything stopping the wind. So wrapping our home, or air sealing our homes, is the equivalent to wearing a windbreaker. So when it comes to home improvements, air sealing is your number one. Then we move on to insulation. Now we all know that insulation helps stop resists the flow of heat, okay? But where does heat flow? It actually flows in all directions equally. Now, we talked about hot air rising, but this is just energy. And again, no one ever teaches us this. We don't really learn this. If we do, we forget it. But when I started looking into residential energy, I thought, well, if heat flows in all directions equally, like, why do we put all of this insulation in our attic and like not really much in our walls and maybe none in our basement? Can anybody tell me why? Can anybody guess why we might, if energy or heat flows in all directions, why don't we insulate? Why do we put more in our attics? Why do we do that? It's just pretty easy. It's pretty easy.
Heat rises.
No, not because heat rises. It's easier to do. Ross?
No, go ahead.
It's easier to do. We have huge, ginormous attics usually, but there's nothing special about the attic that determines more energy loss. What do we have in Wisconsin, like below our first floors, that not all states do?
Basements.
Basements. Okay. And below the frost line, what do we know about the ground temperature? Anybody know anything about the ground temperature below the frost line?
Oh, 55.
It's about like 45 to 50 or like around that, but it stays consistent. So when we talk about putting insulation in places that matter, we don't have as much heat loss in our basements because it's all below grade, right? It's like that top first 4 feet that actually that are the frost line and above, where you could have the majority of energy transfer happening. And then our walls. I mean, we have just, typically built with 2x4s for exterior walls. But when I was working in consulting and doing high performance homes, we did have clients building 12-inch walls, right? So they were taking what we could do in the attic and they were doing that in the walls. Right? And ideally, if we were doing everything right, we'd be living in passive homes where it was so insulated that we would just heat from the sun, ideally, right? But we would have to keep all that heat inside, and we need a whole lot of insulation to do that. So I just like people to think gosh, was the Pink Panther just really that popular? Is that why attics are so insulated? It's no, it's because we can actually access them and put that much in there. But it doesn't mean that ideally we shouldn't have that much insulation everywhere else in the house. It's just that's not how we've approached construction. But what do you want in your attic? You want blown-in cellulose ideally, and you want our 50 to 60. We're talking 15, 16 inches of insulation.
It's also, I think, the biggest bang for your buck.
Why? It's not.
Well, because it's easy, like you said, it's easiest.
It's easiest, labor-wise, you mean?
Right.
Yes, totally. Yeah, but there's no more heat that goes.
No.
Yeah, okay, all right. I agree. Yeah, it's easiest, right? You can throw somebody up in the attic and they can just blow the insulation and they're done. Whereas sidewalls, right? And if you live in Monona like I do, that's another reason I love coming to speak here because you are my people. You likely could get your walls dense packed. What does that mean? They temporarily remove a piece of siding and they use a machine that blows in insulation until it reaches a specific density. And our house is a ranch, built in 1959, and we still had our walls dense packed because inside our walls we had about a 2-inch fiberglass bat, but walls are 3.5 inches, so that extra 1.5 inches wasn't due. I mean, it's just empty cavity. Now, I often say, insulation does not stop air, but if you can have your walls dense packed, it does reduce the air movement, okay? Because it gets put in so densely. And then the sill box. This is another area where ideally you would put a closed cell spray foam. And the reason why is because sill boxes are leaky. I would go and do audits on brand new homes and I would think there is no way air is moving through this sill box because there's thousands of pounds of lumber sitting on top of this foundation. How is there gonna be any air moving through there? But there absolutely is air moving through there. In fact, by code, they're required to put something called a sill sealer underneath this, but that doesn't actually stop air. It's actually more there just for vapor retardant of the moisture coming through the foundation wall. And so not only is it a place where all these puzzle pieces come together for building, you've got this 2x4, which is called the sill plate that sits on top of your foundation wall, leakage. Then you've got your sill, your rim joist actually, leakage. And then what do? Well, we poke the gas line through the sill box, we poke the dryer vent, we poke the AC copper tubing, we put the furnace exhaust and intake through. We poke all these holes through the sill box. Why? Well, because it's a lot easier poking holes through wood than it is concrete, but they end up getting mutilated and then we wonder how mice get in. It's okay, well, because we give them all these places. And so ideally you want that to be spray foamed because spray foam is the only insulation that also stops air movement. It's the only one. And this is the type of foam that's used up in the attic when they foam all those nooks and crannies. So You know, the sill box is that other place where not only does it need insulation, but you need to stop the air movement. And then foundation walls. You know, we talked about the fact that they're below grade. Typically, if you're not going to finish, you can still put this foil-faced foam on, but the most important place to do it would be the top 4 feet of the wall, where you're having the majority. So if you just want to do it purely for insulating reasons, you can approach it that way. I talk about windows here just a little bit because I like this graph because, you know, it's just for the amount that windows cost and the small amount of energy savings you get, or maybe none at all, I just really can't say enough about making sure that your attic is air sealed and insulated, and your walls, if need be, dense packed, and your sill box, you know, because what do we get here? Even out of the best triple pane window, you get an R4.3. When our walls are like R13, they're almost triple, right? So you know, there are times to change out your windows, and that's when the seal is broken and you get that kind of fogginess in the middle. They're just not functioning well, you know, they're just not opening and closing well for you. But to change them out for energy reasons, the marketing is not true. And if you get brand new windows and they are airtight, you better have asked the contractor to actually have removed your trim and to foam behind the trim, because there is a small space all around every window, okay? And in the old days, they just shoved fiberglass in there, which fiberglass doesn't stop air. So I've gone to numerous homes doing energy audits where they were so proud of their brand new windows, and they were indeed airtight, but none of the areas around the windows were airtight. And it just would break my heart, because this is what I would see in an infrared camera. Just all that blue is just leakage all around the trim, right? And nobody wants to take off their trim. That would be hard, you know, what if it cracks? But yet you'll spend thousands of dollars on windows, but yet then the area around it is leaky. So, you know, windows are a tricky one. But so we just covered insulation, and I realize I'm moving fast here, but we have so much to cover. But we talked about, so remember, step back, we're talking about what controls that heating and cooling. The house does. That's the first most important thing. So we just covered making that house airtight, which there is a motto, and that motto is build tight, ventilate right. Don't ever let anybody tell you like, oh, no, you don't want to make your house too tight. Then you're not going to have good indoor air quality. That's not true. You want to make that house as airtight as possible, and then you tell it how to breathe. And we're going to talk about that next. But insulation, right? Make sure every insulation that you can get to, you know, is fully insulated. And this is the equivalent to wearing a fleece. Now, if you go outside and it's a cold day and you just have on your windbreaker, you're going to be cold. But if you put on your fleece and you put on your windbreaker, now we're talking, right? And so this is what we want for our homes. So now if you got this airtight house and you're warm and cozy, you do have to think about indoor air quality. But you tell your house how to breathe. You don't want your house just leaking wherever it kind of feels like it, or wherever the last contractor drilled a hole. No, we tell our homes how to breathe. Just like good thing our bodies don't breathe just because we poke holes in them, right? No, we've got this intricate breathing system, and it's called lungs. So we give our house a set of lungs. And what is that? It's our ventilations, it's our fans. And the most important thing about fans is that they are vented to the outside of the attic, not to the attic, but to the outside of the attic, and that they are insulated and that it's hard ducted if possible. And so our ventilation, the lungs of our house, are our bath fans, our kitchen ranges, and if you want to get really fancy, energy recovery ventilators, which I'm not going to get into much, but they are amazing and they deliver They do some heat transfer, and you're constantly getting fresh air from outside, and it's expelling the stale air from inside your house. So we covered air sealing, making the house airtight as possible, insulating, then letting that house breathe, but you letting it know how to breathe, okay? The only other thing that needs to breathe is your attic. Now, why would our attics need to breathe? Like, what's going on up there? Most of us never go up there. We don't want to. It's like the last place you want to be, right? Condensation. But if you air seal your attic and you make sure your fans are venting to the outside of the attic, you should have stopped any condensation because you stopped all the moisture from getting into the attic. Because warm air rises, and what does it carry with it? Humidity, moisture. So when you don't air seal, you are doing yourself a disservice because you are not only allowing heated air that you paid for into your attic, but it's carrying moisture. And I have gone into attics, no lie, that have an entire layer of frost over the entire inside of the attic. And all the nails that came through, they're all super frosty, extra frosty, because they're metal, right? What happens when that melts? Yeah, it drips down onto everything, all the insulation you just paid for. So we need ventilation. So if you do your attic air sealing, you shouldn't have condensation, but I call it the belt and suspenders approach. We ventilate our attics because just in case something gets up there, we want to move that moisture out. And we do it through a number of different ways, but really it should work by letting air in through the soffits and up and out through something on the top, or through, if you have more like a Cape Cod, then you typically have something like this on the side of the house. You would never have all of these. This is just like all the options put in one image. And in order to help that air move from the soffit up to like a ridge or a square vent, you want vent chutes. Lots of people don't have, or some people don't have these, and if you ever have work done, you always want to say, hey, I want you to add those vent chutes because they help ventilate that attic. And one of the biggest things that a good insulator will do is they will make sure that when they insulate, that none of that insulation falls down into the soffit, because that's exactly the place that you need to be able to vent your attic. Sometimes they'll even put like a rigid barrier up there so that nothing falls over here into your soffit vent, because that's where you need your air coming in and up and out. So ventilation, right? Removing moisture, bringing in fresh air. This is the equivalent to opening the armpit vents. Anybody ever have those on their coat? Yeah. I don't use them all that often, but I'm thinking maybe I should. So how could you possibly wrap your head around all of this? Most people can't. They shouldn't. There's people, they're professionals that do this. This is what I did for 12 years. So you get an energy audit. Why? Well, it's somebody who's seen probably thousands of homes if they've been at it for a while. They approach your house as a true system, right? They have all this stuff in their brains. They're realizing, they measure your bath fans. They look to see how your dryer is venting. They recognize how all these things play together, and they actually keep it in their brain, and then they provide you a strategic roadmap. You most certainly can DIY this stuff. I mean, I tried to DIY air seal my attic and do a fair amount of things, right? But I can tell you, it's not always fun, right? It's not the most fun work. But having an audit is by far the best value in that you also get the blower door. So this is what a blower door looks like. So this is the best tool. I loved having the ability to set this up, and then it temporarily aggravates leaks so that you can use your infrared camera and you can find where the leaks are occurring, or areas where insulation may have settled in walls or the contractor just missed. Lots of homes got dense packed or got insulation added to their walls, but it was back before contractors had access to equipment that would pack the insulation in densely. So sometimes when I would do blower doors and I would scan, they would say like, oh, well, back in the 70s, we did have some insulation added, but you could just clearly see like this cavity, the insulation would drop way down here, and then this one happened to be fine, and then this one was a little bit iffy, so you can see all this with a blower door and an infrared camera scan. And the blower door creates 22-mile-per-hour wind on all sides of the house at once. So temporarily, it is a great way to like figure out what the heck is leaking and what is not leaking. And typically, it's one and done. Once you do this stuff, you have the audit, you do the improvements, you're not having to do this again and again and again. Typically, once you have this done, you can just cross it all off the list and know that you can move on, right? But it is important to like say, have your attic air sealed, don't just add attic insulation. And then if you ever have a contractor go up there again, say, whatever you're drilling, like I expect you, and even if you hand them a can of great stuff, you just say like, you're drilling a hole, you need to seal it, right? So what did we just cover? We covered, remember, over 50% of your use is heating and cooling. How do you control that? Mainly the enclosure, because once it's done, you don't have to do anything else. You don't have to think about it. It's just providing you that return on investment for the whole time you're living in the house. It was always kind of a little bittersweet when somebody hired me to do an audit and they would tell me like, oh, our last kid just left for college. We've lived here for, like 25 years. And I just kind of thought like, dang it, I wish I could have been here 25 years ago, because all that return on investment, is happening. And so this is the strategy that I want people to know, that you've got to air seal, insulate, ventilate, and then you can start thinking about products. So what is the next thing then that creates that 50% heating and cooling? It's the products we bring in our houses. And we all know this for the most part. Heating, you want a 95% efficient furnace, 2-stage, ECM motor. We're going to get into this later, but heat pumps, you're going to want an HSPF of 8.1 or higher. Cooling, you're going to be offered heat pumps. Don't be afraid of them. We're going to talk about this. Bringing a smart thermostat in, it's proven that they can provide on average like 8% savings for heating and cooling if you use them the right way. And then the water heater, these are the big 3 heavy hitters in that pie chart. Keep that at 120, but you have to actually measure it. So you take a mug, let your hot water run, and then you take a thermometer, you stick it in there, and you see just how hot is my water. It does not need to be any more than 120. Because our water heaters, they're just like low, medium, high, vacation. They don't actually tell you what the temperature is, so you have to figure that out. So products, other products, well, appliances. We've heard this for eons, buy Energy Star, right? It's just like anytime you're going to buy anything, take a look at that energy label. Just see what's it going to be using. And then anytime you plug anything in, that's called your plug load. Once you take care of that thermal enclosure, what's the next thing? It's this stuff. It's everything you plug in. But, that's harder to like, you have to just try to plug less stuff in, and then you can use smart strips. Have you guys ever heard of smart strips? It's like a power strip, but there's a place where you plug into, like, it's a control, and then say you plug your TV into that, and then you have anything else that you would only use when you're using the TV, like, I don't know, DVD, cable box, like if kids play like a game console, all those things, they don't need power unless the TV's on, because you'd never use them unless the TV's on. So these smart strips, they know like, hey, if the TV's not on, I'm not going to send power to any of those other ancillary things because they don't even need power, because those ancillary things are always using power, even when they're off. and that's what's called phantom energy. But there's so many cool things on the market, you know, like even smart light bulbs, like motion detection. Think about like laundry rooms or closets, places where it's like you really don't need that to stay on, pantries, dawn to dusk light bulbs, and then even smart plugs. So, you know, the enclosure, the products you bring in it, and then the final frontier is our behavior as humans, which I always leave for last because we all know that change can be hard, especially when it comes to our behavior. So I tell people the easiest ways you can do this is just to control your thermostat. And when do you do this? Just start doing it when you sleep, right? For 1 degree every 8 hours, you'll save 1%. So I tell my family, when we sleep, we're gonna save 5%. We'll do it in our sleep, right? So heat goes down to 65 and cooling. And then the other thing is just common sense, right? Heat from the sun, use it in the winter, keep it out in the summer. You can use fans in summer and winter. Winter actually has a setting where you turn the fan to go the other way, so it actually pushes the hot air down, right? And simple things like wash in cold water. But one of my best mantras, favorite mantras is heat the person, not the room, because our houses don't care how warm or cold they are, right? They could give two hoots, right? It's us, it's the people in the homes. And why do we have to heat and cool our entire house? That is so rare, like during the day, that I actually am in all parts of my house, right? So if I'm working from home, I actually got myself a pair of heated slippers, love them. They're rechargeable, and then there's heated vests. And what I love about this is they all run off of like little battery packs that you can get on Amazon, but some of these battery packs you can even charge them from the sun. So if you want to be like all out, you know, and the reason why this matters is because, you know, people run their space heaters and think like, oh, well, you know, I'm just going to heat this little area. But that space heater for a month is going to cost you $60. I think that's on high. Whereas my slippers, if I wear them 8 hours a day for a month, it literally is going to cost me 22 cents. And I can tell you that they make awesome Christmas presents. Yeah. And you can charge them just like your phone. And these heating vests, you do not have to get a fancy one. I kind of like experimented on Amazon. I got one that I think was like $15, and then you do have to have a battery pack, but those also are like as cheap as $15. So another really awesome Christmas present, because there's significant savings. Now, if you're gonna use a space heater, like, you best be turning your heat down at the thermostat, right? Because it's not cheap to run a space heater. And they're all created equal. When I answer the home energy line, I've probably answered 100 calls like, oh, but mine is this model and it says the heat's created this way. Every time I look it up, 1,500 watts on high. Okay. Every single one. Does not matter.
I have a term for that. It's called hair dryer in a box.
Ross is absolutely right. The only time we ever blow a fuse in our house is when somebody's using the hair dryer, because I have 2 daughters. It tells you how much energy it uses. So at MG&E, we have this mantra: use energy efficiently, green the grid, and electrify everything. So we just talked about use energy efficiently. I went through it pretty quick because we have a lot to cover, but now we're going to talk about greening the grid. What are your renewable options? Once you've made your house super efficient and you yourself have made some behavior changes and you're super efficient, then we can start talking about renewables. But we really encourage people, make your home as energy efficient before you choose to put on renewables. We have a number of ways you can do this. MG&E has shared solar. Right now there's a wait list, but we did propose to the Public Service Commission, and fingers crossed. But this is for people who maybe you live in a condo, an apartment, you just can't put solar on your house or you choose not to. You can choose like 0 to 50% of your electricity to come from one of these local solar fields, like there is one at the Middleton Airport, that's where the last one was. And you pay an upfront fee to kind of reserve a number of panels that you need for that amount of energy, but then you know for a certain amount of time that you're locked in at a certain price, and also just that you're supporting local renewable energy. We personally do this because our roof is like middle-aged and not ready to put on solar, and we couple it with Green Power Tomorrow. This is our REC program. Who here has heard of RECs, renewable energy credits? Yeah, RECs are really the currency of the renewable energy market. So anytime energy generator creates renewable energy, MG&E included, we get what's called a REC, and tells you right like which windmill it comes from, which solar, like we get these. We can either keep them for whenever we need them, or we can sell them. We sell them to our customer. It ends up being 1 penny more per kilowatt hour, but then you can know where your energy, you can claim where your energy came from, because they'll take that REC and they'll retire it. And so you can claim then that you just supported that renewable energy production and you have that REC for that. So we do this at 50%, so shared solar and then Green Power Tomorrow. But if you're ready to do renewables on your own rooftop, I cannot speak highly enough of Google Project Sunroof. They have some pretty good solar imaging of roofs, and they give you really nice estimates. If you go online and put in your address, like they'll give you an estimate of how much the system is that you could fit and how much of your bill it would pay. You put in what your bill is, you know. And I've heard that it's fairly accurate. So if you just kind of are curious and want to know, it's really good. It's a really good resource. And then, if none of that is for you, that's okay. Because by 2030, MG&E expects to have 80% fewer carbon emissions just by simply you being our customer. So we are on the path of greening the grid, you know, in a way that the electricity you use by 2030 will have 80% fewer carbon emissions from 2005. There's always like a year where we're basing it off of from. And this is because of global warming. We know we need to move away from coal. We are at 40% reduction of our carbon emissions. And a lot of that has to do with moving away from coal, adding on renewables, and then also supplementing with natural gas to produce electricity. But we are on a path towards net zero carbon electricity by 2050, and we fully believe by 2030 we will have reduced our emissions by 80%, which means simply by being our customer, you will too. And you know, what is Eco Action Tuesdays all focused on? Global warming. So when it comes to energy use, what are we targeting? What are we trying to do? We're trying to reduce our carbon emissions. So this is why we're doing all this, right? We have to use energy more efficiently. We have to green the grid. We have to get the carbon out of the picture. And these are our efforts, right? Once we do those things, that's when we electrify everything. So we move towards using things, move towards things that are using electricity. And this really is, how are we doing for time? 7:30. Okay, so we're gonna move through this. So what is electrification? This is by far the most interesting part of this, we only have, like 15 minutes. So what is electrification? It's simple. It's going from using things that were like gasoline or natural gas to using electricity. Vehicles are perfect example of this. We see this industry changing before our eyes, and we don't question it at all. We see our neighbors get a hybrid. We see our other neighbors get a full electric EV that, just runs on electricity. We don't question this. But why is this happening? Well, it's because transportation tailpipe emissions account for 1/3 of greenhouse gases. So this is an industry that is moving towards becoming greener. What's the next phase? Buildings. But how are we going to do it? We're going to do it with something called heat pump technology. And we're going to do it by changing out things like natural gas fireplaces, cooking ranges and ovens that use natural gas. Now, those two things won't use heat pump technology. You'll just end up getting an electric fireplace. Maybe they eventually will have heat pumps. But cooking ranges, have you heard of induction cooktops? Anybody heard of induction cooktops? Dryers will use heat pump technology. Water heaters will use heat pump technology. And heating and cooling equipment will use heat pump technology. So what is heat pump technology? My intention tonight is to have you leave feeling really comfortable with heat pump technology. You already are, you don't know it, but we're going to revisit it because I can guarantee you will all be questioned within the next 3 to 5 years as to whether you're going to go status quo and replace a piece of equipment with what you've known in the past, or to go into the brave new world and choose a heat pump. And because of global warming and because of the whole theme of Eco Action Tuesdays, we all need to feel comfortable saying yes to heat pump technology. And I hope to have you leave tonight saying okay, I at least believe what she said. I might not remember all of it, but I do. And the exciting part about heat pump technology is that it's 300% efficient. And heat pump technology, just really quickly, is nothing different than the refrigeration cycle, like the thing that keeps our refrigerators cold. It also is the same cycle that runs our air conditioners. But when we talk about heat pump technology for this next generation, it's the fact that it can actually run in reverse and can allow for heating, and we're going to talk about that. But the thing that's really amazing is that it's 300% efficient. How does that even work? As an engineer, when I heard this, I was like, nope, let's stop right there. I need to see the numbers. How does this work, right? That my brain does not compute. That means for every one whatever unit of energy, you're gonna get out 3 to 5. How? And I was like, well, clearly it's just magic, right? That's the only answer. But it's not. The answer is refrigerants and thermodynamics. And, I can tell you that if you're not excited, then you should be, because this is probably the most fun part about this presentation. Because when was the last time you talked about refrigerants, right? What is a refrigerant? Does anybody know, or anybody smart and want to tell me? Okay. Well, it's a working liquid that can go from a liquid to a gas and vice versa. We're going to talk about tonight how it does that, because there is some magic, it seems. But the first refrigerants were toxic and flammable. You can find articles about hospitals starting on fire. It was bad. There was refrigeration possible, but it was really dangerous. And refrigerants are cool in that they can carry 10 times more energy than water or air. We're going to talk about how they do that. But does anybody know what happened in 1928 around refrigerants? Does anybody remember how refrigerators used to work before refrigerants? Ice boxes, yeah, replacing ice, right? Well, this guy, Thomas, I don't know how to say his last name, Midgley Jr., he created the first non-combustible, non-toxic chlorofluorocarbon gas. Who can tell me what it is for $1 million? What's it called? Freon! Yes, and it revolutionized the world. Refrigerators went from 5,000 in the US, 5,000 refrigerators, to tens, hundreds, thousands. People didn't have to have the Iceman come. We could keep food cold. We could even have air conditioning. I mean, it really is mind-blowing. And you all have these things in your house right now. It's how your refrigerator is keeping your food cool. And we get air conditioning, but we never talk about it, just like we never talk about our houses, how our houses work. So I want to talk about it. So this is a picture of a refrigeration cycle. We're going to keep it simple, but right now this is how we get air conditioning. Has anybody ever stood outside during summer by their air conditioning unit that was whirring, you hear it whirring and blowing air? Did you ever feel what temperature that air was? It's warm. Do you want to know, can you figure out why? Why? Why is it throwing out warm air?
It's essentially a heat pump.
It's essentially a heat pump. So where is that heat coming from? Okay. So you're going to have your mind blown right now, okay? So inside your house, right? This is like down by our furnaces. We don't think about, like that's what it looks like, right? You get this refrigerant, and this refrigerant goes through something called an expansion valve. And refrigerants are amazing because when you expand them, they get really cold. So they drop in temperature. So picture this like copper tube that's really, really cold. Then you have a fan blow over it, and voila, you sit in your living room and you're cold, right? And you're comfortable. But what's also happening, and people don't think about this, is that in this moment, that refrigerant is actually absorbing heat. It's removing heat. It's like, wait, okay, hold on, let's say this again. You think you're getting cold air, and you are. But what's also happening, and no one's ever told you, is that this refrigerant in here is absorbing heat. Remember conduction, convection? The heat is transferring into the refrigerant. The heat that was in your house. And then it's traveling to a condenser where it condenses this refrigerant, compressor. The compressor is compressing it. And the other cool thing about a refrigerant is when you compress it, it gets hot. So then it gets really, really hot, and it gets sent outside, and then it gets a fan blown over it, and that's the heat that is leaving your house through that unit outside that we never pay attention to, but it's running. And we always wonder, like, oh, what's that doing? It's our air conditioner. It's transferring the heat from your house outside. We think about air conditioning providing us cold, but it's actually absorbing heat too, and it's throwing it outside, okay? It's waste to us in the summer. But wait, what if we could reverse that and have it be winter? Then that's not waste heat. That's heat that could warm us. And that's exactly what's happening. This cycle, so then that refrigerant goes back and it goes through the expansion device and it gets really cold again, and then it provides, the fan blows over those cold coils, gives us the cold air, absorbs the heat, and it just keeps doing that. And that's the cooling cycle. But what if it could be a heating cycle? And it can. And so this is what a heat pump is. It's your air conditioner running in reverse. And I want to get to rebates, but I want you to understand that when someone offers you a heat pump, it's no different than your air conditioner running in reverse. It's just that in winter, you have this cold coil, but heat goes to cold. And so this very cold coil, which is colder than the outside, is actually absorbing heat. Like, wait a second, what do you mean absorbing heat? It's like -10. No, you can do it because there is heat in the air until -459 degrees Fahrenheit. It's called absolute zero. And until you reach that temperature, there is actually energy in the air. We're just so cold, we don't think about it that way. But if you can take that refrigerant and make it like colder than it is outside, it will actually end up absorbing heat. It takes a while to get your head wrapped around it, but the idea is this is happening all the time. It's the reason why you stand by your refrigerator and you might feel warmth coming from beneath, that's the warmth that the refrigerant just absorbed out of the inside and is throwing out of the refrigerator. And so heat pumps can actually take heat out of the air in winter and bring it into your home. And they can do that for dryers, and they can do that for water heaters. And this is what an air source heat pump looks like, the outside unit. This is what we'll all end up having sitting outside our homes. If you wanted to completely get rid of your natural gas furnace right now, you could. People in Madison have done it. You would have a unit that looks like that in the basement, and it would just be doing that transfer that we talked about, and it would be blowing air over those coils, and those coils would either be hot or cold, transferring the heat. Now, a lot of people still really like the idea of a natural gas furnace, so the beauty of these units is that they can be coupled together, and you can have a natural gas furnace and a heat pump. And so then what you have is something that looks like this, which is a natural gas furnace, and the coils are just sitting up there inside. You can't see it, but you can then have your natural gas furnace providing heat. You could choose your heat pump to provide heat and your heat pump to provide cooling. And you can use these in combination.
Can you talk a little bit about boilers for people who have radiators?
I will talk offline about that because I want to get to that, but that's a possibility too. Yep. So all of this is possible with heat pump technology, and then also the last thing is just induction cooktops. This is like another step. But people always ask, what's it going to do to my bill? Okay, like yeah, I can get a heat pump, but what is it going to do to my bill? If you get a dual fuel where you use your natural gas furnace the majority of the time, and maybe only use your heat pump for cooling, and then like heating, in the spring and fall, you'll probably be about cost neutral. Right? If you just used an air source heat pump for heating, you're going to end up paying a little bit more. But I always tell people more is in comparison to something our brains already know. And what that more is incredibly low natural gas prices, because the US has had plentiful domestic natural gas, and we reap the rewards. But because of global warming and fracking, we also reap those not rewards. And so we come from a time where it is very economical to use natural gas. If natural gas were to increase, we'd all be running out to get a heat pump, because then it would be cheaper. It's all based off of what we know and compare things to. And this is what we've compared our heating bills to: super economical natural gas. So Rocky Mountain Institute is a nonprofit that is all about greening the grid and bringing on electrification. So you don't have to take my word for it. They did an actual article about Wisconsin and do heat pumps actually reduce emissions in Wisconsin where coal's still on the grid? Over the lifetime of this equipment, because they last 15, 20 years, the answer is yes. Natural gas furnace emissions, high performance air source heat pump. And so people say, why would I switch to a heat pump? And I say, well, if it's for environmental reasons, you can feel confident leaving tonight knowing that if it is for environmental reasons, which is why most of you are here, that this is a valid reason to choose a heat pump. Okay, so if these are so great and wonderful, how do we, what's happening is the federal government is saying this needs to happen, it needs to happen fast, we need adoption, we need to move towards electrification. So they are providing people rebates. There are 4 main buckets. Two of them fall under the Inflation Reduction Act. One is called HERE, one is called HOMES. Focus on Energy, FOE, is our state program and state rebates, and then tax credit. Let's everybody take a second. The IRA rebates are based off of income, and it is like your line 9 on your 1040, which is like your income before deductions. So it's pretty much your total taxable income. If you are if you are below, and it's all based on how many people are in your home, if you are under this number, then you're gonna be one set of rebates. If you're over this number but under this number, you're gonna be in another set of rebates. This is our state rebates, and you have the papers that you have, there's links to all of these charts. So don't even feel like, you can take pictures if you want, but like, we created this, and you'll have access to all this.
And if you want them to, MG&E to email you this document with the links, so you can just click on the links, fill out your email address and name on there, and they will send it to you.
So there's lots of charts, there's lots of things to navigate, okay? But everybody wants to know, how does this play out for me in the real world? So I'm gonna run through a scenario, okay? Let's say you're in that 0 to 80% AMI, okay? In year 1, you have an energy audit, which would be free. Federal government's gonna pay for that. And let's say you decide to air seal and just insulate your attic, those two things. Based off of the Focus on Energy rewards and the Inflation Reduction Act homes program, you won't pay anything out of pocket if you're in that 0 to 80 area median income. Pretty good deal. If in year 2 you say, my water heater died, and I'm gonna go ahead and go into that brave new world, and I'm gonna get a heat pump water heater, but your electrician says, but you gotta actually upgrade your panel. You don't have, what it takes to deal with this heat pump water heater. Well, if you're in that 0 to 80, your out of pocket is only gonna be about $2,000, even though it's about $8,500 worth of work. If you're in that 0 to 80, you gotta be a mover and shaker and make this stuff happen, because I've never seen this amount of money before for energy upgrades in a house. If you're in the 0 to 80 and it's year 3, maybe it's time then for a heat pump and a furnace. And the federal government is gonna give you $8,000. Well, they'll give you 100% up to $8,000, but a furnace and a heat pump is probably gonna be about $14,000, it might even be more. But you're gonna get a Focus on Energy, and then you're gonna get tax credit. And for this amount of equipment, that's what you'll pay out of pocket. So these next two, I don't even have done because you run out of the federal rebate, so I just wanted to show it when people took advantage of that. But look at these numbers. This is wild. If you did all this, you would get this amount, of value for this net cost, assuming you have a tax liability. But this is what would come out of your pocket, and then if you had a tax liability. That's like somebody handing you an 80% off coupon. Like, just has never happened. If you're in the 80 to 150 bracket, this is what yours is gonna play out to be like. It's the same scenario. You have an energy audit, that is gonna cost you $500, but there's a tax credit. But you gotta have the audit in order to get this homes money.
Can you say that again? That's so important.
You have to have an audit to get the homes IRA money. We'll talk about that, but I know we're running out of time. But if you're in the 80 to 150, this is still phenomenal. That's like somebody handing you a coupon that says you get 63% off. And these are all things that everybody's gonna need done to their house anyway. If you're in the 150 and over, it's still nothing to sneeze at. I still cut out coupons that are 25% off. I mean, we're all real people here with real checkbooks. But inevitably somebody in this room's water heater is going to die in the next year or two, and you're going to have to make a decision, or your dryer might die, or you might need a new cooktop, or you're going to need a new air conditioning unit, and then you're going to realize, wow, there's these credits. But probably the one that's most mind-blowing is if you are in the 0 to 80 and you have an audit and you can do enough upgrades to achieve like 35% savings, then you can get 100% of that work done up to $10,000 covered for free. And so then you're looking at something more like an 88% discount. So how does this all happen? Well, it's all through our state. It's all through our state. Let me see if I can close this. You have all these links. Oh, it doesn't want to. Oh yeah, okay. You have all these links, and this is not showing on my screen, so this is really hard for me to do. I don't know why. Let me see if I close this.
Does this have to do with the advertising you do for zip codes and getting money back for windows and things? They say if you live in the zip code of 535 or 545 or something, you're eligible for them? There's advertising
Laura
on
I'll
television.
answer that, and we will be wrapping up in probably 3, 4, 5 minutes. That's a scam.
Okay.
Ignore it.
All the links are here. You go to the Focus on Energy website. There's an awesome rebate finder. You can figure out what's all available to you. There is a great roadmap. This is all in there. The first thing you do is you say you want to get started. You get income qualified, okay, and then you want to find a contractor. This link is in there. You find contractors that because they have to participate and be registered with the IRA Focus on Energy program. They will tell you what they do when you click on them, whether they are going to do like insulation, energy assessments, HVAC, and there also is in there an energy advisor map. So there is Jason Kempen is our local IRA Homes contact should you have questions, but I'm also here to help at the home energy line, which number is there, or that email. It's a lot to navigate, but the whole point is that there's a whole lot of money on the table, and yet a lot of it is around heat pump technology. And so you have to feel okay with this heat pump technology, and you should, because your refrigerator uses it, your air conditioner uses it, and any new piece of equipment like a dryer, a water heater, or your heating and cooling, equipment, it's not black magic. It's actually really efficient, and it is the way of the future for heating and cooling homes and water, and it's how we are going to tackle global warming. So, yeah.
So, time check, 7:55. When do we have to be out of here? Now, 8 o'clock. So, I don't mean to interrupt, Laura, but I think we gotta pull it away and wrap it up.
Yep. Are there any burning questions though?
As far as the heat pump technology, you have individual furnace, individual air conditioner, individual dryer, and then the heat pump works for all of those things? Or you have a heat pump for each thing?
No, the heat pump's within the dryer. Like you buy a heat pump
So it's-
dryer.
Okay,
Yep. And then the water heater would have its own little heat pump in it.
okay.
Yep.
Did you say line 40 on the text?
Line 9. Line
Line
9.
You're
9.
qualifying,
Yep, that's what the income line is.
How recent do you have to have had an audit? Because we've had one, but it's been a while.
Yes, they talk about that, and you can retrofit. I mean, not retrofit, you can retroactive. If you go on that homes website, it has some fine line there. So if you have one, you can use it.
For multiple years, then if you start
Yes, you can use it for multiple years. But if your income changes, then you have to get income qualified again. That's only good for like a year. Yeah.
Thank you.
Yeah, thank you.